Hello, once again, welcome, and let's talk about floating point numbers in this video. So this is where we left off in the last video, where we spoke about the different data types that we can use to declare integers, and now we want to talk about floating point numbers. Okay, so floating point, and in Rust we only have two types, which is F32 and F64. So I'm going to get rid of all this, and I'm going to leave two of them here so that we can reuse. Okay, so first of all, I want to mention that we have two types for the floating point number data type, and in case you're wondering why are they called floating point in the first place, they are called floating point because the numbers raddest point, that is the decimal point, can float. It means it can be placed anywhere. Okay, so let me first of all comment out these guys. We'll come back to it, and let's declare a floating point number. And I'm sure the commonest floating point number that everybody who loves math knows about is pi. Okay, so I'll say let pi is equal to 3.142, just like that. Just by including the decimal point in the value makes it a floating point data type, and Rust by default assumes the F64 data type if you don't specify a specific data type that you want to use. It's going to infer from the number. Okay, so let's come here and do a regular print, and I'm going to print the value of pi, and I'm going to put pi here. And so let's come down here and do our usual cargo run, and you can see that we have a floating point number, which is pi. Okay, we could also use the surface annotation that we learned about in the previous video to also make sure that it is an F64. If you want to make it an F32, we are free to also change it to F32, and Rust is happily going to accept that as long as the value doesn't go out of range. And in a very short time, I'm going to show you how to see the minimum and maximum values that the F32 and F64 can take. Okay, so you have seen the surface annotation. We could also have done it this way, F64, and then you don't need to annotate it twice. So I can also remove it here, and you can see that we have the same program output. Nothing much has changed. Okay, if we wanted F32, we could also do F32, and now we can come here and run it, and you can see that nothing much has changed. Okay, now the question is, what is the range of values that an F32 can take, and what is the range of values that the F64 data type can take? Okay, so I'm going to uncomment these guys, and I'm going to comment out these guys because we don't need them anymore. And so minimum of F32 and maximum of F32, let's change to F32, let's change to F32, and minimum of F64 and maximum of F64, let's change to F64, and let's change this to F64. Okay, so this is going to help us to know the smallest and the biggest numbers that we can fit into our variables depending on the data type that we chose. So let's see, cargo run, and woo, these are rather huge numbers. Imagine, look at this. Look at this. I mean, what at all will you be doing that would demand that you have to use all this capability? Just imagine, count the number of zeros. I mean, it's almost too huge for any purpose that I can conceive. But I mean, there are cases where these are important, especially when you are doing some mission critical scientific applications. They can come in handy, but this is a rather huge capacity that we have to be able to fit in a very huge range of different floating point numbers. So this is it for floating point data types in Rust. Remember that Rust is going to default to F64 if you don't specify the data type, and it has to infer the type from the context. Okay, so always make sure you specify F32 if you really need F32. Otherwise, it is going to use F64. And these are all going to affect how much space your program occupies in memory, because all these space will have to be reserved because your values have the capability to grow and fit into those capacities. So thank you very much for watching, and I'll see you in the next video.